The Space Launch System, NASA's new and powerful heavy launch vehicle. It is designed to take astronauts and payloads beyond low Earth orbit and into deep space. Is this the most powerful rocket NASA has ever made? Will the co-host gather enough technology and materials to launch his own rocket? Find out next on NASA Edge.
Welcome to NASA Edge.
An inside and outside look
at all things NASA.
I can't believe this is our 100th episode.
I'm amazed, actually. I'm very excited that we're still doing this and still having fun at the same time.
6 years doing the show. I wouldn't rather be here with anybody other than you guys.
What about our fans? I mean, without the fan support, this wouldn't be happening.
That's right. And in honor of our fans, everyone go out there and download each episode 100 times. It'd be a little celebratory activity.
Tell a friend.
That's right. But on today's show, we have a jam-packed show, and we're going to be talking about SLS, or NASA's Space Launch System. The SLS will be taking astronauts and science experiments farther into space than ever before.
And on this show, we're going to be bringing you a lot of information about the SLS and how it was made, its rockets, and we'll even talk to a model maker who was making models of SLS.
And don't forget NASA Edge's own contribution to the program, which we'll hear about later.
But first, let's go and talk with Todd May, who's the SLS program manager, and he can kind of fill us in what SLS is all about.
Hey, so Todd, we're celebrating our 100th episode, and what better way than to celebrate it with SLS?
Well, thank you for that honor, and congratulations on 100 episodes. That speaks well of your program. SLS is the Space Launch System. It's the nation's next heavy lift launch vehicle designed to take humans beyond the bounds that have constrained us for the last 40 plus years.
The Space Launch System involves a pretty big rocket, doesn't it?
Even in the initial configuration, it's as tall as the Statue of Liberty, to put it in perspective.
Wow. Now, how's that compared to, let's say, the Saturn V back there in the Apollo program?
It's a little smaller than the Saturn V in terms of initial configuration. When we get to the ultimate Block 2 capability, it'll actually be taller than the Saturn V. Even in the first launch, it'll have 10% more thrust off the pad than the Saturn V did.
It seems like if you have to go beyond low Earth orbit, if you want to go to the moon, you want to go to the asteroids, to Lagrange points, or the Mars, you need a pretty big rocket just to get up there, don't you?
You do if you want to take humans to those places, because us humans are fairly needy people. We need our water and our food and our clothes and our laundry and our teddy bears for those long trips.
You know, we were talking offline earlier, and you talked about this the difference between a 1969 Stingray and then a 2014 Stingray. Talk about that analogy, comparing it to rockets.
So we saw an old picture of the Apollo astronauts next to a bunch of Stingrays that Alan Bean had evidently designed the color scheme for. And we happened to also hear the other day on the radio about the new Stingray they're coming out with in 2014. And in some ways, we like to think of it as this is not your grandfather's Stingray, this is not your grandfather's rocket. Right. The new Stingrays have completely new designs on the inside. The outside has roughly the same dimensions, but it has computer health monitoring, nano composites. It actually gets better gas mileage than we had in the past. In the same way, we use a lot of the same components we had on the Saturn V, like the J2X engines, or on the shuttle, like the RS-25 main engines or the boosters.
You know, some people might think, well, you're using old technology from the shuttle days and before, but you're actually not, because you've improved that technology over the past 30 years.
That's right. So just for example, the RS-25 engines have actually been through 7 different evolutions over the time of the shuttle flights. And even today, it is the state of the art in terms of stage combustion. Right. As an example, one of those engines has as much power as 8 Hoover dams.
Wow.
It can empty a family-sized swimming pool in 25 seconds. It has over 100 horsepower per pound. So if you think of a Corvette at 600 horsepower, that's like designing a Corvette that weighs only 6 pounds.
Is this technically going to be the workhorse for NASA, for the next 5, 10, 20, 30 years?
Well, so we have a couple of different paths. The shuttle actually used to take people to and from low Earth orbit. The agency and the nation has decided that we want to enable commercial crew and cargo to and from low Earth orbit, while we NASA focus on the longer strides. So this will be the workhorse for heavy cargo and humans out beyond things like the moon and Mars and asteroids.
So it really, essentially, it's not going to make any sense to use an SLS cargo version, let's say 130 metric ton, to go to low Earth orbit.
Unless you wanted to put something very big in low Earth orbit.
Maybe a hotel.
We could. We have a friend in Mr. Bigelow out in Las Vegas, and he designs inflatable habitation modules. One of his concepts is the Bigelow 2100, which is about 45 feet long and can fit 16 people inside of it. We can actually launch that thing in one launch on a Space Launch System.
It took all the shuttle launches it took to build Space Station. Now you're saying with just a few launches with SLS, I mean, you could put a huge hotel in space, or a huge complex.
It's really a great enabler on a number of fronts. Mass to orbit is one, volume to orbit is another, and the ability to take humans in very long reach capability.
Now, where do you see the technology currently today in terms, let's say, the materials and the structure of SLS compared to, let's say, the Saturn V?
Sure. So a couple of major things in terms of just the basic structure. Things like we used to use simply aluminum as part of the super lightweight external tank on shuttle. We learned about super lightweight aluminum lithium. We intend to use some of that on the SLS. We also went from old historical welding techniques like variable polarity plasma arc welding to friction stir welding and self-reacting friction stir welding. And so in our welding techniques now, we have much more efficient ways of welding things up, much more stable ways.
Is that sort of a seamless weld?
Sure. So you butt the pieces up together and you start to stir, and you actually semi-melt the two materials together, and it forms a very clean weld line. It actually improves manufacturability and performance in terms of the weld itself.
What are some of the advancements in technologies that you might see in the near future, or what you're working on today?
Oh, we've got a couple of areas where we're working on some really interesting things. One is called selective laser melting. You may have heard of three-dimensional printing, where you build up complex structures with a laser printer. So now we can actually do the same thing with high-performance materials like those that would make engine components. And so we're actually testing that out today, such that one day we can actually make engine components for 1/10 of the normal cost.
This particular rocket is really a game changer for NASA and for the world.
In terms of the capability, it really does open up the frontier. It also allows us to press forward out into the solar system in ways we haven't done in over 40 years.
You know, I wonder if for the 100th episode we can get 3 Stingrays.
2014 models?
2014 models.
That's appropriate. I mean, really, when you think about it, if we're media-nauts, we should be honored in the same way that the astronauts are honored. We should get Stingrays.
That's right. There's 3 of us, 3 of the astronauts for Apollo 12. Yeah.
Well, as a media-naut, I can actually put the Blair Media-Naut bobblehead on my dashboard.
Hey, speaking of fun facts, I got a fun fact for you, all right?
All right.
We talked about Corvettes and Stingrays.
Yes.
The SLS, the first version that we talked about, that's going to have Orion on top. In terms of power, it's going to have 8.4 million pounds of thrust. How many Corvettes would that be equivalent to?
486,000.
I'll say 486,001.
And one. Dun, 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 dun. It's 160,000 Corvettes.
Well, that's still quite a bit.
That's a lot of Corvettes.
Yeah.
Now, if you have the 130 metric ton rocket, which is later down the road, that's 208,000 Corvettes.
I was doing the math.
Oh, okay.
That's what I would have said.
Well, speaking of propulsion and rockets, Blair, you did an interview.
Actually, I did, and it's good we're talking about that, because really a lot of the externals on SLS look the same as the old Apollo, but it's the inside where you start to see really all the difference. And I learned about that when we talked to Catherine Van Hooser down at Marshall.
This was your 100th episode interview.
Yes, I'm going to preface everything with that from now on.
Hey, let's check it out.
So, Catherine, I understand that you're very involved in the overall propulsion system for the SLS, which we're very excited about, by the way. I was just wondering, how do you design a propulsion system for a new space vehicle?
Well, a lot goes into that, and it takes a long time and a lot of people. We work very closely with the people who design the vehicle. That's the first thing you have to do, figure out where you want your vehicle to go, how big is it, how much propulsion do you need. Then there are lots of trades that go on trying to size the engine, what type of engine, what kind of propellants. A lot of work goes back and forth between the engine and the stage.
Now, we're not developing a new engine for the SLS. We're using the Space Shuttle's engine, is that correct?
That's exactly right. At the end of the Space Shuttle program, we were lucky enough to be able to manipulate our assets in such a way that we saved several flights on 15 engines, and we have enough parts to build a 16th engine. So we had 16 usable Space Shuttle main engines left at the end of the program. SLS decided to use those engines as part of its vehicle. So we're going to use those 16 first, and then after that, if we have to make more, we'll do that. And that'll give us some opportunities to put in some cost-saving mechanisms, because SLS is not a reusable vehicle like the Space Shuttle was. So we'll be able to improve some manufacturing techniques and do things a little more simply and a little more cost-effective, because the engines won't have to be reused.
You have these 16 motors, and they're sort of legacy motors from the shuttle program.
Right.
You've been using those motors for a while, so they're not new. So have we made some improvements or upgrades on those motors over the years?
Of course, SSME was continually upgraded over the years. The contract was awarded in 1971, and we first built hardware in 72. First Space Shuttle mission was in 1981, and at the end of the program, we were still flying hardware that had flown as part of the engines on STS-1.
Wow.
So some of the hardware is 30 years old. The design itself, much of it, 40 years old, but it has been continually improved. The engines at the end of the Space Shuttle program were 4 times more reliable than they were at the beginning of the program, and took 57% less time to maintain than they did early in the program. So we've upgraded a lot of the major components, turbopumps, nozzles, chambers. A lot of the major components have gone over upgrades over the years. One of the reasons that SSME was so successful with the shuttle program is that it was a very well understood engine. We have over 1 million seconds of hot fire time. That's ground test and flight time on that engine. It's the most
Hot fire time.
Hot fire time.
Wow, that's a lot of seconds.
Because that includes ground test and flight, that is a lot of time. And so we have a bulk of data, a lot of data to analyze and help us understand how the engine works and what it's doing that's not ideal, what we can do to make it better. So we use all of that data to do our upgrades. Another big benefit of the Space Shuttle program is that because the engines were reusable, when they came home, we would do inspections, periodically take components apart, and see how the hardware performed. And that let us know what areas we needed to improve the most.
What's the difference between the F1 that was used on the Saturn rockets and what's now being developed for SLS?
Oh, that's a good question. The F1, developed a long time ago, actually has more thrust. It's a larger engine. It uses RP1, which is like kerosene and liquid oxygen, so the stuff coming out of it is a black sooty residue. That's what's left on the hardware. The RS-25 being used for SLS uses liquid hydrogen and liquid oxygen. It's roughly 1/3 the thrust, but it's a much more efficient engine. The way the engine operates itself causes it to be much more efficient. You get a lot more thrust for the amount of propellant that you consume. And the exhaust from a Space Shuttle main engine or the RS-25 is a hydrogen-rich steam. So when you take our hardware apart, it all looks steam cleaned. It looks just like it did when it went in.
As far as propellant's concerned, and these are important questions, you can choose between whether you're going to use solid or you're going to use liquid. So what goes into the decision when you're trying to figure out which propellant you want to use?
Well, I've worked on liquid engines my whole life, so obviously that's the better choice.
But tried and true in your case, right?
Tried and true.
Yeah.
They both have important places in rocketry. Solid rockets tend to give you a lot more thrust, but for a shorter amount of time, and they're less efficient. So you use those to get off the ground, where you need the most thrust at that point in your launch. And so SLS will use, just like Shuttle did, a combination at liftoff, and then the solids will fall away, and the liquids will continue to burn for the rest of the mission.
You know, you've got these extra shuttle motors that you're using, but I can think of about 4 locations around the country where there might be some in existence that aren't being used. Maybe I could borrow those, or at least look into them being accessed.
I think you might mean the museums where we've put the orbiters around the country.
I might be thinking of the museums.
Well, good luck. Since we finished the shuttle program with flights remaining on all of our engines, we did save those for SLS. We knew SLS was coming along. So what's in the orbiters that are around the country for viewing are not SSMEs, they are RSMEs. They're replica shuttle main engines. They have development or older nozzles nozzles that you see. Everything you see is a real part of an SSME, but the part that's inside the orbiter that's hidden from view is just support structure. We needed the engines for future use.
Now, did the museums know they were getting replicas?
They do. They absolutely know, and they know why.
Okay. Oh,
and they,
all right.
as good Americans, they completely support it.
With all due respect, I mean, I really appreciate what Catherine had to say, but I need some verification that the museums don't have actual rocket motors in the shuttles around the country.
Well, you can actually go over to these museums on your own and do a little bit of
I'm gonna have to do that.
snooping.
Oh yeah, I'm good at that.
Would you like another 100th anniversary fun fact? On
Yeah,
SLS?
sure. Why
Real
not?
quick?
Fun fact. Let's roll
Okay,
with it.
how much will SLS weigh in terms of 747 jumbo jets? So let's take the 70 metric ton rocket. How many jumbo jets?
100 jumbo jets.
100 jumbo jets. What do you think?
10.
He's much closer. 7.5 747 jumbo jets is
But
equivalent to the weight of the SLS.
But it's
70
our
metric ton version.
But it's our 100th episode.
See, you were thinking of like a scaled down model version.
Yeah.
Well, speaking of scaled down model version, and Franklin with this 100th episode segue.
Yes.
Who knew? Had an opportunity to talk to Barry Howe at the Marshall Space Flight Center about making models and the SLS.
Supermodels.
Yeah.
Ooh.
Ooh.
So Barry, when you first started, you had 30 to 40 people working in the shop. Now you're down to about 3 model makers.
Yeah.
Has technology enabled, you guys to do more with less?
It certainly has. In the past, the way we used to do things was we had to machine each part.
Now, back in the day, you used to use blueprints.
We used to have blueprints, yes.
And now
it's computer generated drawing, not a lot of detail to what we got. So we take that, we scale it down and try to pick out what we think the customer would want as far as detail. Some customer wants a lot of details in there. Some of them just want something that looks like the SLS, but of course with more detail it costs a little more to do it. So
now, when you first walked in the door as a 19-year-old, you started working on the Saturn 1B.
Saturn 1B, Saturn 5, all the Saturn vehicles, the old Block 1, the 2, but the Saturn 5 and the 1B were the most that we built.
The materials that you're using to build the SLS models are way different than what you used to build your Saturn.
Absolutely. Used to the old Saturn parts, you used aluminum tubing, you used plexiglass. But nowadays we use the 2-part mixture that we just add together. It dries in 15 minutes, you got your part. So instead of standing at a machine, turning a piece of plexiglass down for an hour, you can take this liquid, mix it together, in 15 minutes you got a part.
When I first walked into your shop, I walked over to your area and you had a crawler on the desk.
Yeah.
And it was huge. What are you actually working on right now?
Actually, right now I am building a 1:50 scale crawler and launch tower for the SLS. The tower is going to be 88 inches tall.
88?
88. I think it's going to be a floor model versus a 1:100. So crawler and all, it's going to be tall.
Tall. I'm only 73 inches, so I'm assuming you're working on some step ladders and.
Yeah. I'll be working off of a ladder. But actually, I'm building it in such a way that it comes in sections. So you cut down on your shipping of it, and it'd be easier just to assemble.
So in 44 years, you gotta be honest with me right now, Barry. Have you ever just took an X-Acto knife and carved your initials somewhere on the inside?
Probably have in the past. I wouldn't know where the model went to. You got to put your mark somewhere. So yeah, probably I have.
Do you get the information like, okay, we're making this model that's going to go to the White House? Have you ever received any, information like that?
I can't say that we have. Most of the time we don't know where the models are going, but we have models at the White House. But I don't, at the time when we was building, we didn't know where they was going, so we don't know.
There's a BH on one of those right there somewhere.
I'd like to think so, but I wouldn't know that. Yes.
When you finally leave Marshall, they'll probably make a model of you.
It'll be a short one.
Tell you what, Franklin, did you by chance put any NASA Edge stickers or signage on the models?
Well, like Barry, I can neither confirm nor deny whether or not there is a NASA Edge sticker on anything over in the model shop, but...
if you find it there, don't be surprised. How about that?
Yeah, I like that right there.
Well, I tell you what, we learned quite a bit today.
Absolutely.
And in fact, in 2017, when we had the first flight test for SLS down at Kennedy, hopefully we will be there in person with the live show.
I'll tell you what, guys. I mean, that'll be great when we're there, probably episode 168.
No, it could be episode 200.
Or 200. Yeah. We're down there watching that launch. You can reflect on what I'm about to show you on this 100th episode of NASA Edge. Care to venture a guess?
You have your own model?
Okay. All right. You know the surprise, but I have constructed...
Well, you have it on your desk.
That's the initial box. That's not the completed thing. But for you guys, for this 100th episode, I am going to show you now footage of the very first maiden flight of NASA Edge SLS-X, the first flyable demonstration of technology that will eventually take CoRian into space.
Now, do you have CoRian on this model?
I have a test flight article CoRian. It's not the full-scale version. It's obviously been scaled down for safety reasons, but it's a legitimate flight.
We knew about CoRian, but didn't know anything about this.
I tell you, man, progress is progress. You guys sit around and you conduct your meetings, but it's time to launch.
All right, well, let's go check out this 100th episode flight test.
Show me what you got.
Go ahead, and 5, 4.
Catch it, catch it.
Success! Now if we can just find the capsule. Anyone seen CoRian?